Hello and welcome to this Python tutorial. So in the previous tutorial we imported the required libraries to build our future artificial neural network, and so now we're going to start building our deep learning model. And we're going to build this model in two parts. Part 1 will be data preprocessing, which I've prepared here, and part 2 will only be about creating the ANN model. So let's start with part 1. And you will understand in this tutorial why it's so important to prepare the data correctly to build a future deep learning model. So, as you understood in the business problem description explained by Kirill, we are in front of a classification problem. So we have some independent variables, which are some informations about customers in a bank, and we are trying to predict a binary outcome for the dependent variable, which is either 1 if the customer leaves the bank, and 0 if the customer stays in the bank. So this is a classification problem, and therefore I've prepared here our classification template, which we made in part 3, classification. So basically what we're going to do now is take everything in this template except the visualizing part, because we have many independent variables. We have more than 10 independent variables. So of course we have nothing to visualize here in terms of prediction regions and prediction boundary, because simply we have more than 2 independent variables. So we take everything from importing the libraries to here, because in the end we'll have a look at the confusion matrix to evaluate the performance of our ANN model. So we will take this whole section and go back to our ANN model and paste everything here. All right, so let's handle each of the sections here one by one. Let's start with the first one, importing the libraries. So let's take this code section here and execute. Here we go, libraries well imported. Great. Now, second code section, importing the dataset. So before importing the dataset, what we need to do is to set the right folder as a working directory. By the way, as you might have noticed, I just updated the latest version release of Spyder, and therefore we can observe some minor changes in Spyder. For example, Object Inspector was replaced by Help, and then we no longer have this little button here to set the folder as working directory. This has been replaced by this Options button here. Here it is, and that's how you set your folder as working directory. But before, of course, we need to choose the right folder. So we go to File Explorer, we go to our Machine Learning AZ folder, and then part 8, Deep Learning, and section 40, Artificial Neural Networks. Here we go. That's the right folder we want to set as a working directory. Make sure that you have the churn modeling CSV file, and if that's the case, you can click on this Options button here, and then click on Set Console Working Directory. Here we go. Everything's fine. Now we can import the dataset. So let's do it. The dataset is not social networks ads.csv. It is now churn underscore modeling.csv. All right, perfect. So let's import it. Great. While imported, now let's go to Variable Explorer to have a quick look. Here it is. That's our dataset. So, quick reminder, this dataset are informations of customers in a bank. The bank gathered these informations and at the same time observed if the customer stayed or left the bank within a 6 months period of time. And so the key thing to understand here is that all these variables here are independent variables, and the last column here, exited, is our dependent variable. And so we are trying to predict the results of this exited dependent variable from the informations of these independent variables. And we're going to do that with an artificial neural network. All right, so let's press OK. And now the next thing that we have to do is to create the matrix X of features. And to do that, we need to input the right indexes here. So to have an idea of what these indexes are, we need to go back to our dataset and see which independent variables we want to include in our matrix of features, because our matrix of features is nothing else than our matrix containing the independent variables. All right, so let's do it. We have all our variables here, and let's look at them one by one. First column is row number. Row number has, of course, no impact on the decision of the customer to leave or stay in the bank, so we won't include this variable in our matrix of features. Second variable, customer ID, same, absolutely no impact on the dependent variable. All right, third column, surname, well, that's the same. It's not because your name is Andrews that you have more chance to leave the bank than if your name is McDonald. All right, so that has absolutely no impact on the dependent variable, and therefore we won't include the surname variable either. Now, next variable, credit score. Well, credit score, yes. The credit score is very likely to have an impact on the decision of the customer to stay in the bank or leave the bank. If we think about it, we might expect that customers with a low credit score are more likely to leave the bank than customers with a high credit score. So definitely, that's the first independent variable that we'll include in our matrix of features. All right, then geography. Geography, yes. Perhaps customers in France are more likely to leave the bank than customers in Germany. So we'll include that as well. Gender, yes, same. Perhaps men are more likely to leave the bank than women. We never know. We have to check it out. Then age. Age, well, of course. Young people might be more likely to leave the bank than older people that not only have more stability, but also might have been in a bank for a longer period of time and therefore are more likely to stay. All right, then tenure. Tenure is how long the customer has been in the bank. Of course, this might have an impact on the decision to stay or leave the bank, so we include that as well. Balance, same. Of course, a customer with a zero balance has more chance to leave the bank than a customer with a high balance. Number of products, we never know, it might have an impact, we'll include that as well. Has credit card? Yes, maybe. We might expect that customers with a credit card are more likely to stay in the bank than customers who don't have a credit card, so we have to check it out as well. Is active member? Well, same logic as here. If a customer is active, then he might be more likely to stay in the bank. And eventually, estimated salary, well, that's the same logic as balance. Customers with a high estimated salary might be more likely to stay in the bank than customers with low estimated salaries. So with our own logic, we are able to say which independent variables might have impact on the dependent variable, but what we don't know is which independent variable has the most impact on the dependent variable. And that's what our artificial neural network will spot and will perfectly see by looking at the correlations here, and therefore it will give the bigger weight in the neural network to those independent variables that have the most impact. All right, so now we know which independent variables to include in our matrix of features. That's all the independent variables from credit score to the last one, estimated salary. And so let's see what the indexes of these independent variables are. So let's see, indexes in Python start at 0. So that's 0 here, 1, 2, 3. Okay, so we'll go from 3 to 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All right, so we must include the indexes from 3 to 12. So let's do it. Let's press OK here. All right, so we need to take the indexes from 3 to 12. This takes the indexes 2 and 3. And so to take the indexes from 3 to 12, we need to add the lower bound here, index 3, colon, and then the upper bound, but remember the upper bound is excluded in a range. So instead of putting 12, we need to put 13. And that takes all the indexes from 3 to 12. All right, good. So now we are ready to create our matrix of features X. And so let's select this line and execute. Great. Matrix of features X created. All right. And now let's create our dependent variable vector. So that's very easy. You know, remember our independent variables are taking indexes from 3 to 12. And therefore the index of our dependent variable is index number 13. And therefore instead of 4 here, we input 13. All right. So we are ready to build the dependent variable vector. So let's select this line and execute. All right, here we go. We can have a look. Y contains the binary outcomes 0 or 1 for all the 10,000 customers of this sample of this bank. All right, so let's press OK. We are done with importing the dataset, Everything is well prepared. Now let's move on to the next code section. The next code section is about splitting the dataset into the training set and the test set. But before we do that, we must pay attention to something. We must fix something before splitting the dataset into the training set and the test set. Can you guess what it is? Well, it's of course related to the fact that we have some categorical variables in our matrix of features, and therefore we need to encode them exactly as we did in part 1, data preprocessing. And that is why I've also prepared the categorical data.py file right here, and therefore in this file we will take this code section here that encodes any categorical data that you have in your dataset. So, by the way, our dependent variable is categorical, but it takes values 0 or 1, so it takes numerical values, so we don't need to apply label encoder to, encode text into numbers. But we have our independent variables, which have categories that are strings, and therefore we need to take this code section here that will encode the categorical independent variables. Alright, so I'm taking this, copy, and going back to my ANN file, and we will encode the categorical data before splitting the data set into the training set and the test set. Because basically when you do this split, your matrix of features X and your dependent variable Y must be already encoded. Alright, so I'm pasting that here. Here we go. I'm going to remove that. That was just to make the distinction between the independent variable and the dependent variable. And now we will encode our categorical independent variables. So let's see what they are. We will have a look at our matrix of features from the console. So I'm pressing X here, and let's have a look. Alright, so these are all our independent variables. We can very clearly and quickly see here that we only have two categorical independent variables, which are the country, which contains three categories, France, Spain, and Germany, and the gender variable, which contains two categories, female and male. So these are the only two variables we need to encode in our matrix of features. So let's do it. Let's take care of the first one, the country. All right, so since we will need to encode two variables, we will need to create two label encoder objects here, and therefore we will call the first one label encoder underscore x underscore 1. All right, so here we create the object, and then in the next line we apply the fit transform method to encode this variable. That is, it will convert the strings here, France, Spain, and Germany, into numbers 0, 1, and 2. So that's the first step of the encoding. So let's do it. We need to put the right index here, which is not 0, but of course 1, because indexes in Python start at 0. So that's index 0 and that's index 1. That's the index we want. All right, great. And same here. We replace 0 by 1. All right, good. Let's not forget to add this underscore 1 here to take this object created here. And so I'm going to select these three lines here, and this will convert the strings into three numbers. All right, so well executed. Now let's have a look at X. Here we go, and that's it. So as you can see, France became 0, Spain became 2, and Germany became 1. All right, and now let's take care of the second categorical variable, the gender variable. So we will do exactly the same as we did here, but only with a new object. So I'm going to copy this, copy, and paste it here. And here I will not only change the name of the label encoder object, which I will replace by label encoder x2, right? And let's not forget to replace that here as well. And of course, we need to change the index here, which corresponds to the index of the independent variable we want to encode. And therefore, that's of course the index number 2, 0, 1, and 2. All right, so we replace 1 by 2 here, and same as well. All right, and that's done. We just need to select this and execute. All right, now let's have a look at X. X here, here we go. And as you can see, female became 0 and male became 1. I hope the ladies of this course won't be offended, but that's pure random. All right, so now we need to do one more thing. which is of course related to the fact that our categorical variables are not ordinal. That means that there is no relational order between the categories of our categorical variables. That is, France is not higher than Germany, and Germany is not higher than France, and same between Spain and Germany, and Spain and France. Alright, so exactly as we did in part 1, we need to create dummy variables for this categorical variable, and we will only do it for this categorical variable of the country because it contains 3 categories, and this one contains 2 categories. So since we will then remove one column to avoid the dummy variable trap, well, it will be no use to create dummy variables for this one. So let's just do it for this one, and we already have everything prepared here with the OneHot encoder class that will create these dummy variables. We don't even need to change the index because that corresponds to the right index of the column we want to create the dummy variables for. Indeed, that is index 1. Alright, so basically we're ready, and we can just select that here to create the dummy variables. Alright, done. Well executed. Now we can have a look at X, and actually, since now all the columns have the same type, we can have a look at X from here because the type is no longer an object but float64. So let's have a look, and we can clearly see all the independent variables of our matrix of features. Alright, so we now have 12 independent variables because we have our 3 new dummy variables. I'm going to change the format very quickly. 0. Okay. Alright, so these are our 3 dummy variables corresponding to the country. And then here we have the credit score. Then here the categorical variable corresponding to the gender. And then the other independent variables. So that's great, but now we will remove one dummy variable here to avoid falling into the dummy variable trap. Alright, so let's do that right now. It's going to be very quick and easy. We take our matrix of features X and we will update it by taking all the lines of this matrix and all the columns except the first one. And to do this, I'm taking all the columns from index 1, which corresponds to the second column, until the last index of the last column. Alright, and that will do it. I'm going to select this and execute. And now, as you can see, we only have 2 dummy variables for the country, which is great. So no more dummy variable trap. Alright, so we're good. We are ready to split the data set into the training set and the test set. So that's exactly what we do in this section. Everything is ready. We will maybe change the test size to 0.2 to, train the ANN on 8,000 observations and test its performance on 2,000 observations. So let's do it. I'm going to select these 3 lines here and execute. And here we get something new. We get a deprecation warning. That is fine. It's just because Spyder was updated to its latest version. And in this latest version, well, this cross validation package here was replaced by model selection. So basically, to avoid this warning, this is fine. This perfectly created a training set and a test set. But to avoid the warning, we just need to replace cross validation here by model selection. All right, and now if I reselect that and execute, as you can see, the warning disappears. All right, so that's good to know, and that can be useful to avoid future errors. All right, and now time for feature scaling. Do we need to apply feature scaling to artificial neural networks and in general deep learning? Well, the answer is yes, absolutely. That is thoroughly compulsory. And that is because there is going to be a lot of computations, highly compute intensive calculations, and besides parallel computations. So we need to apply feature scaling to ease all these calculations. And besides, we don't want to have one independent variable dominating another one. So very important, we need to apply feature scaling. That's really compulsory. So let's do it. Everything is ready here. I don't need to change anything. So let's execute, and all good. No warning. Feature scaling done properly. We can have a quick look at xtrain here. As you can see, all the independent variables are scaled, and that's the same for the test set. Everything is scaled properly. we are all good. Our data is now well pre-processed. And now I'm super excited because we are about to start building the artificial neural network. This is going to be something. We are now approaching one of the most powerful tools in machine learning that I'm sure will be very useful if you need to apply them for your work. So we're going to do that in the next tutorial, and